Hello, this little video is going to be all over parallel and perpendicular lines. So let's check it out. So you can see here, I've got notes here on parallel lines and perpendicular lines, but I'm going to work out of Desmos mainly besides my paper here. So if we go to Desmos, I've encouraged you to create an account. And you can do that up here at the right where it says my name. You can create a free account. You can use it on your phone. It's easier on your laptop, but you can use it on your phone. And I have my two definitions here of parallel and perpendicular lines. Parallel lines have the same slope. Okay, the same slope. So let's just see what that would look like. So I'm going to do an equation of a line. And I'm just going to make one up here. My equation is 2x plus 5. And then I'm going to make it another equation that has the same slope, but my y-intercept is going to be negative. I'm going to make it -6. So notice that they have the same slope, meaning that they move and grow. In this case, they grow because they have a positive slope. Their slope is 2, but their slope moves and grows at the same rate. Okay, so I'm going to try to create one with some sliders here. So the only thing that's going to be changing is the slope. And I'm going to do it as 2. And so my slider M is just going to change. And you can just see how that slope, when the slope is negative, the further negative it gets, the more up and down that slope becomes. And then when it gets to 0, it goes flat. And then when it gets positive, it's going up and down. And then there it is at 2 to match my slopes of the parallel lines. Okay, so let's look at the example that I have in our notes here. I want to, and it's right here. I want to find an equation for the line parallel to -4x plus y equals 8. So the equation is a -4x plus y equals 8, and we want to pass through another point at a -1, 2. And then we want to write the equation in slope-intercept form. So I'm going to show you my paper, and don't worry, I've written it all down on my paper. I also want to encourage you to print out the notes. I've linked those notes in Canvas. So we're going to find an equation for the line parallel to this one. So we said that parallel lines have the same slope. Okay, so we have to find out what the slope is. But to find that slope, we have to put this into slope-intercept form, which means I need to have y equals. So I'm going to add 4x to both sides. So we have y equals 4x plus 8. Now I'm in slope-intercept form, and I can see that my slope is equal to 4. So my new line will have my slope equal to 4 and go through a -1, 2. So that means that my equation, remember my new equation is going to look something like this: 4x plus whatever my y-intercept is down here. This is my goal down here. And so right now I have y equals 4x plus b. And I know that a -1, 2 is a point on this line. So whatever my y-intercept is should make this a true statement if I put a -1 in for x and 2 in for y. So 2 equals 4 times a -1 is a -4 plus b. And so to solve for b, I have to add 4 so that this is 0. And then add 4. So this is 6. So this is my equation. So b is left on the right, and then I have 2 plus 4 is 6. So my y-intercept is 6. Y-intercept is at 0, 6. Okay, so my new equation must be 4x plus 6. And that verifies that it has the same slope as my other equation. So this is exciting. Let's go to Desmos and put in these two equations. They should look parallel like what we showed before. And we should be able to see that this point, a -1, 2, goes on that new line, just like we had planned. So let's go back here to Desmos. Here. Okay. So I'm going to just make those so they are not showing. Save this real quick. Okay. So let's go ahead and look at my new line, y equals 4x plus 6. And I am going to validate that it is parallel. Y equals 4x plus 8. And yep, you can visually see that it is parallel. I'm going to click on my 4x plus 6 line. And what's cool is when you type in an equation, does everybody see where this, right up here where it says edit list, where my mouse is? If you click on that and then go to the line y equals 4x plus 6 and click on this convert to table, we can then see a -1, 2 right here. A -1, 2 is the point that we wanted to go through. And so that proves that that point is on the line that we created. It's pretty exciting, isn't it? Okay, so I am going to delete those for now. Okay, so let's look at perpendicular lines. So perpendicular lines are lines that have slopes that are negative reciprocals of one another. And so that sounds kind of scary, negative reciprocals. Okay. Negative reciprocals. So that means they're negative of each other. If one is negative, the other is positive. So we know that. And reciprocal means that they're like numerator and denominators are flipped. Okay. So I need to rename that because I spelled parallel incorrect. And that's going to drive me crazy. I still spelled it incorrect. Okay. So let's go back to my paper for a minute. And I'm going to give you some example of, actually, I'm just going to write it here in my Desmos. So parallel slopes could be, reciprocals could be 1/2, or, and then it would be -2/1. Those would be reciprocals. Their fractions are opposite of each other. Okay, so 1/2, and then a -2, a -2/1. Let me retype that because that was not correct. Okay, so those are reciprocal. 1/2 and a -2/1 are reciprocal fractions, reciprocal. So they would be reciprocal slopes. So let's just graph two lines that are reciprocal so you can see what they would look like, what visually this would look like. So if one had 2x plus 3, a reciprocal line, a perpendicular line that has negative reciprocal slopes would be y equals a negative 1/2 x plus 4, we'll say. Okay, so they are reciprocals. They are perpendicular lines because their slopes are negative reciprocals. Now the 2 doesn't show the 2/1, but a whole number doesn't actually show when its denominator is 1. But you can see this is what they should look like. Okay, so let's go to our notes here. And this is what we want to do. It says, find an equation for the line perpendicular to 4x plus 2y minus 3 equals 0 and passing through 2, -1. Write the equation in slope-intercept form. So let's write down the equation that they gave us, 4x plus 2y minus 3 equals 0. And we want to pass through the new point 2, -1. Okay. So here we are. So first off, I have to figure out what my slope is. Now, it's not in slope-intercept form, so that means it's important that we get it in that form so we can pull out the slope, because it's not necessarily 4. We've got other things going on here. So that means we need to get everything to the right except for the y term. So we're going to leave the y. We're going to subtract 4x. We're going to add 3 to both sides. I'm going to subtract 4x and add 3. So we have 2y equals a -4x plus 3. Then in in the slope-intercept form, we have to divide by 2 because y needs to be by itself. So we're going to divide by 2, divide by 2. So y equals a -4 divided by 2 is a -2x plus 3 halves, 3 divided by 2. Now I'm in slope-intercept form. So and when we're talking about perpendicular lines, I like to denote them as M old for my old or original line, and then my M new for my new line so that I can keep them straight. So my slope on the original line is a -2/1. And I like to write it over 1 because I'm doing that reciprocal thing, right? So that means my M new, if my M old is negative, my M new is going to be positive, and then I'm just flipping my fraction here. So it's going to be 1/2. Okay, so that's going to be my new slope. And then I want to go through the point 2, -1. Okay, so y equals 1/2 x plus b. And so my line down here is going to be 1/2 x plus, we don't know what that's going to be yet. We got to find out what our y-intercept is. But I know that 2 and -1 make my line true. So y is a -1, 1/2 times 2 for x plus b. This becomes a -1. 1/2 times 2 is 2/2 plus b. And that becomes a -1 equals 1 plus b. And then I'm solving for b, so I have to subtract 1 from both sides to get b alone. And so b appears to be a -2. Okay, so it looks like my y-intercept is 0 and a -2. So let's go to Desmos. We're going to validate that these two lines here look perpendicular to one another. And we want to make sure that on our new line, the slope is 1/2, which we're typing in, and that we want to make sure that the point 2, -1 is also on that slope. Let's go to Desmos to do this. There it is. Okay. I'm going to turn off those 2 graphs for now. So our old equation is y equals a negative 2x plus, and I like to put fractions in parentheses just so it all stays together. And then the new line we came up with is y equals a negative 1/2 x, and we said it's negative 2. And those don't look, oh, you know why? Because my original slope was a negative. This slope has to be positive. I typed it in incorrectly. Now they look like they're perpendicular. That's exciting. And on my second line, I'm going to just turn off my first line. My second line that we created, let's go ahead and go up to the gear. I'm going to click on the gear and I'm going to make a table. And I just want to validate that the point a negative 2, I'm sorry, a positive 2 and 1, a positive 2 and negative 1, this is main, does fall. So I'm just going to type this so you can all see. 2, negative 1. Oh no, where'd that type that? Right here. 2, negative 1. A point on the, okay, there we go. So we created parallel lines, we created perpendicular lines. So those are the perpendicular lines that we created. And then I'm going to go up here and I'm going to turn on the 2 parallel lines that we created. So that's exciting. Okay, catch me back for some more interesting items and topics.